Greetings, this is Greg. The Boeing 727, at least as I see it, is more than just an airliner. It represents a number of philosophies that I just don't see anymore in civil aviation, certainly not from Boeing. Let's get into this. If you watched my recent video on the Douglas DC-7, you probably know that in 1958, jet airliners took over the long-haul passenger flying from the propeller-driven airplanes. By long haul, I'm talking about transatlantic, transcontinental, and Pacific Ocean flying. The Boeing 707 and the Douglas DC-8 were the two dominant airplanes in this market. However, a huge portion of the airline passenger market at the time was in short and medium haul work. Think Cleveland to Denver, London to Frankfurt, Amsterdam to Paris, stuff like that. That market was largely taken up by turboprop aircraft like the Vickers Viscount or the Lockheed Electra. These planes have advantages in fuel costs, and they could get in and out of airports with much shorter runways than the jets. This was a big factor at the time. The people at Boeing were going all in on jets. They felt that jet-powered airliners were the future, but overcoming the turboprop's advantages on shorter segments and to smaller airports was going to be a challenge. Before I go any farther, I should say I'm using mainly two sources for this video. This book is one of them. I'll put pages up on screen occasionally for certain subjects. You can pause and read them if you want some extra detail, but there isn't a need to do that. If you like the 727, this book is well worth hunting down. It's out of print, but of course still covered by copyright. The second source for this video is me. I generally don't use myself as a source for videos on this channel, but I do have a lot of time in the 727 as a flight engineer and as a co-pilot. Unfortunately, I was never a captain on this plane. Airline bankruptcies and closures saw to that. I suppose it all ended well, though, as I'm currently captain on a 767. Back to our story, the engineers at Boeing felt they could build a jet that could overcome the inherent advantages of turboprops on shorter flights, but that it would require a clean slate design and would likely be a very expensive airplane, expensive to develop and expensive for the customer to purchase. Now, they did come out with the Boeing 720s, that's 720, seen here. This is really just a short fuselage 707 intended for short and medium haul flights in and out of smaller airports. The economics of this plane were not too good, and it was not really successful in those markets. They needed a clean sheet design, and that design ended up being the 727. Someone in the comments on my channel asked why the 727 wasn't called the 717 since it came out after the 707. There appear to be two reasons for that. The 717 designation was already being used internally at Boeing, and also the 720 was out, and the subsequent design should have a higher number in the sequence, hence 727. There was a big problem looming on the horizon for what was to become the 727. This was a problem that almost killed the airplane before it got started. It's a problem you hear about all the time, as it's still a factor in business today. But Boeing's solution was something you don't often hear anymore. The problem was cheap foreign labor. Workers in the United States were relatively expensive in the 1950s and the 1960s. Boeing would have to compete in a segment of the market against French and British companies with far lower labor costs. British wages were less than half those in the US. French wages were even lower. By the way, when I said cheap foreign labor, you weren't thinking of Europe, were you? Things change over time, but the principles remain. There have always been lower labor costs available somewhere, and of course there still is. The difference here is in the way Boeing overcame the problem. Now, this is going to sound like a cliche or one of those stupid motivational posters pseudo-intellectual managers like to put up. The difference is it's real. Boeing really said this, meant it, and did it. They decided to make the airplane so good that the additional expense wouldn't really matter to the customer. It would be recovered in operational profits for the airlines who purchased the plane many times over. In other words, sure, the plane costs a lot more than its competition, but it makes more money every flight because it carries more, thus has lower operating costs considering its revenue payload. It's also more reliable, and when it does break down, it's easy to repair. So it stays in the air making money more often than its lower-priced competitors. The 727 was also very fast and could be operated in and out of small airports. These two capabilities were not often seen together in one airliner, and both have value to the customer. The plane would also have auto-land and Cat 3 capability. In simple terms, that meant it could take off and land in low visibility conditions that would ground most of the competition. All of these things would enable the 727 to make more money per flight or per unit of time and fly more often than the competition. In short, they decided to spare almost no expense and make the plane so good, so much better than the competition, that airlines, in order to remain competitive, would have to buy it. This really is what they did, and in the end, it worked out very well. Of course, there were dissenting opinions at Boeing on this project. Some suggested outsourcing, take advantage of that low-cost foreign labor. Some wanted to kill the 727 program outright, considering it impossible to compete with the lower-cost products on the market. Now, I know some of my regular viewers are thinking, Greg, what the heck? We come here for technical stuff, and you're going off on this rant about labor costs and business principles. I guess I sort of am, but I promise I'll throw in some technical stuff about the plane as we move along, but that's not really the intent of this video. I'm doing something different here. Another principle that I think has been largely lost in U.S. industry is an appreciation for the value of labor, meaning engineers, the workers on the factory floor, and so on. Today, the focus, more often than not, seems to be on outsourcing, getting that labor for less. At the time the 727 was designed, the idea was very different. That's not to say there isn't always a give and take between labor and management. Of course there is, but it was different then. Boeing's management thinking at the time was that they should capitalize on the skills they had in their workforce and profit from that. It wasn't that they should reduce the cost of that workforce via layoffs or pay cuts. In fact, management considered it their job to find or create projects that would do just that and keep the factory running. I notice that management today is always looking for a way to eliminate U.S. manufacturing and move production somewhere else. And there are a lot of reasons for that. I'm not only blaming management. Now you might ask, how did these ideas on building the 727 work out for Boeing? By any standard of measurement, it worked out very well. The 727 was profitable and they sold a lot of them. By comparison, here is a French Caravelle. I think it's a beautiful airplane. And I say it's French, but there's quite a bit of British here as well. Those cockpit windows might look familiar to you. They're the same as on the British de Havilland Comet. Now, how often have you seen a Caravelle flying? I've never seen one of these things in the air. In fact, I've only ever seen one as a static display at the Cincinnati airport. That was a number of years ago. I'm not sure if it's still there. Fewer than 300 of these were built. The only U.S. major airline to use them was United, and then in very small numbers. Some other airlines use them too, but again, always in small numbers and for very short periods of time. It's the same story with the Hawker Siddeley Trident. This plane looks a lot like the 727 and actually came out first. However, it didn't sell well either. Only 117 were built. I have literally never seen one of these things in real life. And keep in mind, I've been a pilot for about 40 years, so I've spent my time at airports and I've seen a lot of airplanes, but I have never seen a Trident. They're just that rare. So how did that cheap foreign labor work out? Well, clearly not well. There were about 4.5 times more 727s built than both of those other airplanes combined. Furthermore, the 727s stayed in service in significant numbers far longer. In the 1980s, if you went to an airport, 727s were everywhere. You couldn't swing a dead cat without hitting one of these things. In fact, the 727 stayed in mainline service with major airlines all over the world until about 2002. In fact, from the 1970s into the late 1990s, if you were a new hire pilot at a U.S. airline, odds are very strong that your first position there was as a flight engineer on the 727 before moving up to the co-pilot seat and ultimately captain. Now, let's talk about what made this plane so attractive to the airlines, and I'll start with the easy stuff. The 727 could go into airports that didn't have jetways, stair trucks, or other ways to get passengers on and off the airplane. It could do this because there was a staircase built into the back of the airplane, making it self-sufficient for enplaning and deplaning passengers. The stairs could be raised and lowered via powered hydraulics or via a hand pump. This is inside of a 727 freighter. The door giving access to the stairs is open in this picture. That door is part of the pressure bulkhead. The actual area containing the stairs is unpressurized. You can see the ducting for the number 2 engine above the stairs. To the left and right of the stairs, various bits of equipment are located in positions that give easy access for the mechanics. These stairs are what D.B. Cooper used to famously parachute from a 727 after hijacking it. The fact that he knew not only how to drop the stairs in flight, but also that the plane had to be depressurized first, means he either really did his homework and did it before the information age, or at some point worked on or around 727s. As a result of that hijacking, all the 727s had a device installed to prevent this from happening again. I don't remember what the actual name of it was, but everybody called it the DB Cooper switch. It was a simple flap that, due to airflow when the plane was flying, would pivot in such a way as to physically block the stairs from descending. The switch could be defeated from inside of the airplane by an especially clever hijacker with some basic tools, but it didn't matter. Nobody ever duplicated DB Cooper's hijacking again. Sometime in the late 1990s, they started removing all of the DB Cooper switches. Another feature was the auxiliary power unit. We take these for granted today. It was a little jet engine mounted crosswise through the keel beam of the airplane. Its intake was in a main gear wheel well, and it exhausted out through the top of the wing. This thing could provide air conditioning, heating, and electrical power, allowing the plane to be operated at airports without adequate support in terms of cooling and heating and ground power units. Now, that APU, or auxiliary power unit, couldn't run when the plane was flying because with the gear up, it wouldn't be able to inhale any air. Its air intake was in the wheel well. But it didn't matter much. With 3 engines on the airplane, all of them turning generators, there was really never a need to start up the APU in flight anyway. That said, I think it could actually be done. And 727 guys, hear me out on this. I did do it once in the simulator. Let me explain. Back when I was a flight engineer, I finished my annual check ride pretty early, like 30 minutes early or so, and I passed it. It was a good check ride. The examiner, who I knew, and I knew him pretty well, said, "Hey, we have some time left. Is there anything else you want to try?" Now, this is Greg giving you airline pilot career advice right now. If you have already passed your check ride and the examiner asks you if you want to do something else in the simulator just for fun, the answer to that is no, especially if you're a new hire and you just passed your check ride. No good can come at that point from further exposure. However, in this case, I'd been at the airline a number of years. I knew everyone else involved, and we were all airlining out to our homes later that day, so we were all fat on time. So what I did was manually crack open the main gear door, which you could do from the cockpit. There was a whole procedure for manual gear extension in case the hydraulics failed. You would put the gear handle in one position, do the other thing with the hydraulic switches, and you find this crank, which was a specialized crank on board the aircraft for this purpose. Then crank the chosen gear. And anyway, I cranked it just enough to crack open the desired gear door, left side if I'm remembering my 727 systems correctly. The APU started and operated normally. So this works in theory and it works in the simulator, but officially the APU in the 727 cannot be used in flight, nor can I think of a realistic scenario where you would ever need to do that. Anyway, the 727 could self-sustain at airports, not set up for passenger jets. That's my point about the stairs in the APU. And that was of a lot of value to airlines at the time. What about taking off and landing at smaller airports with smaller runways? This was a real problem, and the solution was in the wing design. When talking about airliner performance, you're often talking about the wing. The fuselage is really just a tube which connects things and contains things. Okay, it's more than that. There's a lot of engineering in the fuselage, but most of the airframe design work is in the wing. The 727 was going to need to go fast and have a high Mach number, which it did. Depending on the version, it had a Mach limit of either 0.88 or 0.90, and it could easily reach that and stay there as long as you wanted to or until you ran out of fuel. Usually, depending on what we were doing when I was operating these things, we would run them between 0.80 and 0.86. Usually 0.84 to 0.86, although the companies usually wanted you to go at 0.80. But anyway, I flew with this one fellow from Texas that ran the plane on the Mach limit the entire flight every time. We probably sent some speed records from Cincinnati to Dallas. Of course, the problem isn't just designing a wing that can go fast. It's doing that and having a wing that can also fly slowly for takeoff and landing performance on short runways. The engineers at Boeing designed an incredibly complex system of leading-edge flaps and slats along with a complex trailing-edge flap setup that transformed that Mach 0.90 wing into a wing that was great at low speeds. Furthermore, the system was incredibly reliable. In about 11 years on that plane, I never had an actual flap or slat malfunction. Now, I had indication malfunctions in this system, but never once a situation in which the devices were not actually in the selected position. I wasn't flying new 727s either. I started flying them in 1998. Production had ended 14 years earlier, and the airline I flew for didn't have the late production planes. In fact, one day I flew to Chicago. On layover there, I went to the Museum of Science and Industry, and they had a 727 on display, probably still do. That 727 on display in the Museum of Science and Industry was a newer serial number than the one I had just flown there. Speaking of serial numbers, that reminds me, I should mention that there were two different fuselage lengths. You may have noticed that in the pictures. The original shorter 727s were the 727-100s, model number, not a serial number. And then there were longer 727-200s. But for purposes of this discussion, they're really not much different from each other. I suppose it's also worth mentioning that Boeing actually numbered the airplanes by customer, not quite model number. For example, you won't fly on a 727-200. Not exactly. The 200 is a series. The actual plane will be a 727-223, a -214, or whatever. The number is a Boeing customer code. For example, a 727-221 would have been a Pan Am airplane. Now, someone else may have bought it, may have even bought it before Pan Am took delivery of it. I don't know that that ever happened, but it would still be a 221. Boeing still does this, but with the 727, it was a bit different. When the 727s were built, Boeing offered a huge amount of customization based on customer desires. One extreme example of this is if you're on a 727-221, a Pan Am airplane, and then you get on a 231, which was TWA, you will find that the switches on the overhead panel are all reversed. Forward is on for the 221 and off for the 231. The reason was that at TWA, the flight engineer ran the entire overhead panel, except I think the pitot heat. And on the flight engineer's panel, up is on. On the overhead panel, it slopes up as it goes aft. So to keep the switchology theory of operation consistent for the flight engineer, all the switches are different on a TWA 727 on the overhead panel. Now, all of this works out just fine. If you are getting a job at, say, United Airlines, you show up to work, get on your 727-222, and move along with your day. Where this high level of customization starts to cause some chaos is when you go to work at one of the many ACMI airlines in the 1990s or 2000s, which I did. These airlines would have a mix of whatever 727s they could get. You might be in a 223 one day. That was the most common type at Kitty Hawk. Then a 214 the next day. Once you got used to this as a pilot or a flight engineer, it really wasn't bad. In fact, it was kind of fun. But there were certainly mechanics that hated this, and so did the parts department. Now, the idea of offering customers a huge amount of customization made sense at the time because before the 727 came out, airliners did not stay in service very long. Aircraft had been progressing so fast from the time of the Wright brothers up until about 1964 that in order to remain competitive, airlines had to have the latest airliners. Generally speaking, up to that point, airliners only stayed in service with major airlines for 5 to 10 years. There were a few exceptions, the Douglas DC-3 for example, but normally planes were phased out pretty quickly. For example, the Boeing Stratocruiser was one of the most advanced airliners of its time. Pan Am put them into service in 1949, but started phasing them out in the 1950s. By 1961, the sole remaining Stratocruiser at Pan Am was retired. 12 years was a long time for an airliner. United retired all the Stratocruisers in 1954 after the plane had only been out for 5 years. So along comes the 727 in 1964. Judging from history at that point, it would be around until about 1970, probably linger until 1976 or so. But that's not what happened. 727 stayed in mainline service with most major airlines until September of 2001. That's 37 years of mainline service. Even after that, the 727s were still a major player in the charter and cargo industries for almost another 10 years. Now today, only a handful of airlines are using 727s, but there are still some out there. Why did the plane stay in service so long? Well, there are two main reasons. First, it was a really good airplane and it made money. Second, aircraft performance in general kind of hit a brick wall right around 1964. Airliners never really got much faster. They did get more fuel efficient and also quieter due to newer engines coming on the scene. In terms of noise, I'm talking about the noise on the ground, not in the airplane. The 727 passenger cabin was actually nice and quiet. It was the noise on the ground that was the problem. When the plane initially came out, it was thought of as quiet as compared to other airliners. Some called it the whisper jet, and it was legitimately quiet compared to a straight pipe 707 or DC-8 or something. But By the 1980s, it was one of the louder planes in the sky, and new noise restrictions started to cause problems for 727 operators, and that's another story entirely. I want to change gears for a moment and talk about the 727's wing. I'm not going to cover much technical stuff in this video, but the basics of the wing design are really worth mentioning. As you probably know, a wing that's great for high-speed flying usually isn't so great for flying at low speeds. That means a high-speed wing will usually mean you're going to need a long runway for takeoff and landing. That's one of the reasons jet airplanes have wing flaps. These change the shape of the wing, allowing it to operate at lower speeds for takeoff and landing. Retract the flaps after takeoff, you have your high-speed wing. Extend them, it's a low-speed wing again. Of course, I'm oversimplifying, but that's the gist of it. This is a Boeing 767 coming at you, which is one generation newer than the 727. This is a great picture, by the way. Take a look at the inboard trailing edge flaps. They are double slotted flaps, meaning two flaps in one with a slot for each. That slot increases the effectiveness of each flap, but requires some complexity in the mechanism as opposed to a flap that simply pivots down. A double slotted flap requires even more complexity than a single slotted. These are also Fowler flaps, so they're double slotted Fowler flaps. That means they also move back and increase the wing area. Again, more complexity, but more effectiveness. The outboard flaps on the 767 are single slotted Fowler flaps. Now let's compare that with the older generation 727. It has triple slotted Fowlers inboard and outboard. That's a lot of flap. This was expensive to make, but it was the only way to get the takeoff and landing performance out of that high-speed wing, especially the takeoff performance with the engines that were available at the time. Landing performance could be improved somewhat with braking, and the 727 had incredible brakes, even nose wheel brakes in some situations. Now, the 727 had to get its speed from the wing because the engines at the time just didn't have a lot of thrust. To complement those triple-slotted Fowlers at the trailing edge, the 727 uses two different types of leading-edge devices, which are always highly effective. A big part of the 727's success was the flap system. If you compare it to what was on the Hawker-Siddeley Trident, the Hawker's flaps look like they belong on a World War II trainer, not a modern jet airliner. Now, the 727 has three engines. The normal explanation for the three-engine configuration is that one airline wanted a twin-engine airplane, another airline wanted a four-engine airplane. Boeing sort of split the difference in order to try to get orders from both. You'll also hear that it was due to regulatory issues regarding twin-engine airplanes and flights in remote regions or over water. Both of these things are true to a large extent. However, the main reason, or I think the correct way to look at this, is that with the engines available at the time, in order for the plane to be big enough to carry the payload that would make it viable against the cheaper airplanes in existing markets at the plane's price point, it needed to have three engines. Four would have made the plane economically impossible in the short haul segments, and the plane had to be viable for both short and medium haul segments in order to justify its price. I'm oversimplifying this. There is a lot of discussion about this in the book Billion Dollar Battle I mentioned earlier, but it really came down to the capabilities of the plane, the capabilities it needed to have in order to make the economics work out. That just required three engines. I want to take a moment to say please like and subscribe, and I would really appreciate it if you would consider joining my Patreon. I try and give a lot back there. Patreon members get early access to videos, which helps ensure I don't miss your questions or comments, because once the video goes public, I just get an avalanche of comments and have a very difficult, sometimes impossible time keeping up. Patreon members also get access to all the non-copyrighted books and aircraft manuals that have ever been used in any video on this channel, not just the more recent videos. I think it's well worth it. It starts at $1 a month. That's, I think, a very low price. And even the highest tier is only $5, which is where most of my competitors start things out. So again, take a look at that. I'd appreciate it. All right, let's get back to our program. In terms of safety, I think the 727 was very good. In over 50 years of service, I don't know of a single 727 crash that was the airplane's fault or could be attributed to the design of the airplane. Now, there have been a lot of 727 crashes, but the vast majority of those happen when the crew flew a perfectly good airplane into terrain, like the side of a mountain, or descended into the ground or into a lake. These types of crashes were common back then in all types of airplanes and led to improvements in safety, like the installation of ground proximity warning systems in airliners, which are now standard equipment. In fact, it was a 727 accident that ultimately led to the installation of ground proximity warning systems. Pan Am lost a 727 due to wind shear on takeoff. At the time, wind shear wasn't understood to the extent that it is now. Crews were not training for wind shear encounters, but the bigger problem was a lack of understanding about when wind shear would occur and just how serious the risks involved were. It also appears to me that that Pan Am crew went into the ground with the engines at less than maximum thrust, and the 727 doesn't have a whole lot of thrust to begin with. Delta had a crash when a 727 took off without the flaps extended into the takeoff position. This led to changes in the airline industry as well. I could make an entire YouTube channel out of 727 crashes and the industry changes they led to. But I want to stress that not one of these crashes was the fault of the plane, not of the design or anything about the airplane. In other words, no structural failures, no system failures led to crashes, no computers that didn't obey commands led to crashes. Nothing having to do with the airplane caused these 727 crashes. The 727 simply came in at a time when jet airliner operation was still in the early stages of development, and safe operation just wasn't understood as well as it is today. During the first 25 years or so of 727 operations, a lot of things happened that improved airliner safety. Better cockpit procedures, better simulator training, better warning, avoidance, and escape maneuvers for wind shear, as well as better takeoff configuration warnings, ground proximity warning systems, the list goes on. I'm probably going to upset some people at this point, but I would argue that the 737, 747, 757, 767, and 777, aka 777, have all had accidents that were directly related to the design of the airplane. Now, airliners are incredibly safe, and any of those airplanes I just mentioned are about the safest way to travel. But the 727's record is especially impressive in this regard. Side note, I fully realize that the responsibility for the Aero Peru 757 crash is debatable. Some say it wasn't Boeing's fault, although they did have to pay a large settlement to the victims' families. It's a complex issue. I could talk about that crash all day long, but I'm not going to because I don't want to turn this into some sort of crash review channel. Not my thing. Now, the cause of the Lauda 767 crash was disputed by Niki Lauda himself, and he might have been right. I just don't know. Back to the 727, I should also mention that it was designed entirely without computers, and it was the last Boeing design that way. What I mean by that is the engineers were using slide rules to design the airplane, not computers. Today, Boeing has access, of course, to all the computer power they could want, but I don't think they have the same mentality they had back when the 727 was designed, and in fact, I'm sure they don't. The people that designed and built the 727 literally bet the company that regardless of cheap foreign labor, they could build a plane so good it would crush the competition, and they could do this without outsourcing. Today, Boeing hardly even tries. At least that's the way it seems to me. For example, in the US, there are about 45,000 airline flights every day. That represents about half of the world's entire air market. Of those flights, about half of them are on regional airlines. Usually, regional airlines operate jets of 76 seats or less, but sometimes up to 108 seats. How many of those are Boeing aircraft? 0. How many are made in the United States? Again, 0. Boeing has let the foreign companies have that entire market. I don't think Boeing in 1964 would have avoided roughly half of the world's airline market. In fact, we know they wouldn't have because they built the 727, and they built it at a time when they didn't even have any competitive jets in the short and medium haul market. This was at a time when they had serious competition from European aircraft companies who knew how to build good airplanes and had a huge advantage in labor costs. Hawker Siddeley was no joke, and the Trident was a serious contender. I'm disappointed in the Boeing of today. That's all for now. Goodbye and have a great day.